Let's see some examples. Differentiable and non-differentiable complex functions. So first part, show that f z equals z is an entire function. So here we mean define on complex numbers and take complex number values. Secondly, show that f z equals the complex conjugate of z is not differentiable anywhere. Lastly, let's show that fc equals modulus of z squared is differentiable at the origin, but nowhere else. So we can always use Cauchy-Riemann equation to check, but you can also use the definition, right? So let's first see the first one. If we compute delta z goes to 0, fz plus delta z minus fz over delta z, this is delta z goes to 0, delta z over delta z, so this is just constant, and so the limit doesn't change it, so this is differentiable. And in particular, this is telling you that ran is enough. This is true. Secondly, if we take complex conjugate, this would be delta z bar and then delta z, which is, let's see, delta x minus I delta y over delta x plus I delta y. And then you see that you could check that the Cauchy-Riemann equation is not satisfied, so it's not differentiable. But also notice that if we first take delta x equals 0 and then delta y, this equals minus 1, while if we first take delta y equals 0 and then delta x, this is 1. And so it can never be differentiable at any point. It's not. So if you want to check by the Riemann differential equation, what you have to check is that remark partial u, partial x, partial v, partial y. So in this case, fz equals bar equals x minus I y. So this is your ux, this is your uz, or uxy. This is vxy. So partial u partial x is 1, partial v, partial y. Actually, this is minus y. See, minus 1. Already doesn't satisfy the first one. And then partial v, partial x. This is 0. Partial u, partial y is 0. The second one is okay, but the first one doesn't satisfy. And so, Cauchy-Riemann equation is never satisfied. Lastly, let's say this. Fc equals the modulus of the square, so which means f xy z equals x plus I y equals x squared plus y squared. So this is our u, this is our v, wait. There's no imaginary part. This is our u. The v equals 0. Okay. And then if you use Cauchy-Riemann, so suppose at say not f is differentiable, then by Cauchy-Riemann we have partial u partial x equals partial v partial y, and here partial u partial x equals 2x, partial v partial y equals 0. Secondly, partial v partial x equals minus partial u partial y, so partial v partial x is again 0, partial u partial y is 2y minus 2y. This implies x equals 0, y equals 0, so it is only differentiable at the origin.